Hi guys, so today we will be answering problems regarding the slope and equation of tangent lines of a certain function using the limit definition. Now to solve for the slope of the tangent line, we have here the equation limit of f of a plus delta x minus f of a all over delta x as delta x approaches 0, where delta x here is the small change in the x value and a is the x coordinate of a given point. Now, if you're not comfortable using the delta x to represent the change in the x value, you can use the second equation here wherein h is used as a substitute for the delta x. As for the equation of the tangent line, you can use here the point slope form. Y minus y sub 1 equals the slope of the tangent line multiplied by x minus x sub 1. Now, for problem number 1, find the slope and equation of the tangent line given the function y equals 4x minus 3x squared at the point 2, negative 4. So to start, we can solve for a first. And again, a is just the x coordinate of a given point. Here we have the given point. The x coordinate of this one is 2, therefore a is equal to 2. The next step here is to solve for f of a. So f of a will just be equal to f of 2. And to get the f of 2, just replace all variable x with 2. I will have here 4 times 2 minus 3 times 2 squared. This would be equal to 8 minus 3 times 4, that would be 12. Therefore, f of a is equal to negative 4. Next is we will have to solve for the f of a plus delta x, wherein a is equal to 2. So I would have here f of 2 plus delta x. Again, to solve for this one, replace the variable x with 2 plus delta x. So I will have here 4 times 2 plus delta x minus 3 times 2 plus delta x squared. We would have to simplify these terms here. I can distribute 4 to this binomial. I would have here 8 plus 4 delta x. As for the second term, I can expand this binomial here. So if I expand this one using the FOIL method, I would have 4 plus 4 delta x plus delta x squared. Next here is I can distribute negative 3 from the quadratic equation. I would have 8 plus 4 delta x minus 12 delta x, then minus 3 delta x squared. Next is I can combine terms here. I will have here 8 minus 12, that will be negative 4, followed by 4 delta x, then negative 12 delta x. It will become negative 8 delta x. Then copy the last term. I will have here negative 3 delta x squared. So now that we have these two functions here, I can now solve for the slope of the tangent line, and that would be the limit of f of a plus delta x minus f of a divided by delta x as delta x approaches 0. Let's plug in the functions here. For f of a plus delta x, that would be negative 4 minus 8 delta x minus 3 delta x squared. Then minus f of a. F of a is just negative 4. Then all over delta x. I can cancel out negative 4 and negative 4 here. Then I will be left with negative 8 delta x minus 3 delta x squared all over delta x. Next step, to further simplify this one, I can factor out a delta x in the numerator. So I'll be left with negative 8 minus 3 delta x all over delta x. I can cancel this delta x here in the numerator and denominator. So I'll be left with negative 8 minus 3 delta x. So since it is already in its simplest form, I can now solve for its limit. Now to solve for its limit, just replace delta x with 0. So I would have here negative 8 minus 3 times 0. Therefore, the slope of the tangent line here would be equal to negative 8. As for the equation of the tangent line, again, we would use here the point slope form. So we have here y minus y sub 1 equals the slope of the tangent line multiplied by x minus x sub 1. X sub 1, guys, is the x coordinate of the point. Meanwhile, y sub 1 is the y coordinate. So if I plug in those values, I would have y minus negative 4 then equals negative 8 multiplied by x minus x sub 1. X sub 1 is our a, that would be 2. Now, let's further simplify this equation here. On the right side, I would have negative 8x plus 16. Then on the right side, I would have y plus 4. Now, I want my answer, guys, to be in the slope-intercept form. To get that form, let's just transpose positive 4 to the right side of the equation. So the equation of the tangent line here would be equal to y equals negative 8x plus 12. Let's now solve problem number 2. So for problem number 2, we have the function y equals 4 over x squared at the point negative 1, 4. So we would have to find the slope and equation of the tangent line at point negative 1, 4. Now for this problem, I would use here the second equation for the slope of the tangent line. So to start, a here would be the x coordinate of the given point. Therefore, a is equal to negative 1. Next, let's solve for f of a, or that is f of negative 1. So given the function 4 over x squared, f of negative 1 would be 4 over negative 1 squared, or simply 4. Next, I would have to solve for f of a plus h. And since a is equal to negative 1, I would have here f of h minus 1. Now, to solve for h minus 1, f of h minus 1, just replace the variable x with h minus 1. So I would have here 4 over h minus 1 squared. For this function here, I would not yet expand the binomial in the denominator. Let's proceed with the slope of the tangent line. So for the slope of the tangent line, we have here the limit of f of a plus h minus f of a all over h as h approaches 0. Let's plug in our functions. F of a plus h, this would be equal to 4 over h minus 1 squared. F of a is simply 4, or I would write here 4 over 1, then divided by h. Now, to simplify the fraction in the numerator, I would have to subtract them. Now, to subtract them, I would have to multiply 4 and 1. I would have here 4. Copy the operation, minus, then multiply 4 and h minus 1 squared. I would have here 4 times h minus 1 squared. Then divided by the product of the denominators. And that would just be equal to h minus 1 squared. Then divided by h. Now to further simplify this one, we have here division of fractions. So to simplify this one, just place here this h in the denominator to the denominator of the numerator. So I would have here 4 minus 4 times h minus 1 squared divided by h times h minus 1 squared. Next step here is to simplify the numerator. I can now expand the binomial. I would have here 4 minus 4 times the expanded form of h minus 1 squared would be h squared minus 2h plus 1. Then just copy the denominator, h times h minus 1 squared. Let's now distribute negative 4 to the quadratic equation. I would have here 4 minus 4h squared plus 8h and minus 4 all over h times h minus 1 squared. I can simplify this 4 and negative 4. So I will be left with negative 4 h squared plus 8h divided by h times h minus 1 squared. Next step, let's factor out h in the numerator so that I can cancel that one out with the h in the denominator. I would have here h multiplied by negative 4h plus 8, then all over h times h minus 1 squared. So this one cancels out. So I am left with this function 8 minus 4h divided by h minus 1 squared. Now, since the function here is in its simplest form, I can now solve for its limit by replacing the variable h here with 0. So I would have here 8 minus 4 times 0 divided by 0 minus 1 squared. So this one would be 0. And I would have here negative 1 on the denominator. Then square it, that would be positive 1. So the answer here would be 8 over 1. Or simply, the slope of the tangent line would be positive 8. As for the equation of the tangent line, we would use here the point slope form. And that is y minus y sub 1 equals the slope of the tangent line multiplied by x minus x sub 1. Okay. X sub 1 and y sub 1 are negative 1 and 4 respectively. So I can substitute that one together with the slope of the tangent line. So I would have here y minus 4 equals 8 multiplied by x minus negative 1. So let's simplify. I can distribute 8. So I would have here 8. Before I distribute 8, I would have here 8 multiplied by x plus 1. Then copy the left side. I can now distribute 8 to this factor here. So I would have here 8x plus 8. Then on the right side, y minus 4. So the final answer here in slope-intercept form would be y equals 8x plus, if I transpose here negative 4 to the right side, I would have 8 plus 4, and that would be equal to 12. So the final answer here is y equals 8x plus 12. Let's now proceed to problem number 3. For problem number 3, we have here the function y equals 2 over square root of x and the value of a which is equal to 4. So we can start here by solving for f of a, and that would be f of 4. And to solve for f of 4, I will just substitute 4 to the value of x in the function. I would have here 2 over square root of 4, and that would be 2 over 2 or simply 1. Next, let's solve for f of a plus h, and since a is equal to 4, this would be equal to f of 4 plus h, or I can rearrange this one. This would be h plus 4. Now f of h plus 4 would be 2 over square root of h plus 4. Now that we have these two functions, we can now solve for the slope of the tangent line, and that is the limit of f of a plus h minus f of a divided by h as h approaches 0. Next, plug in our functions. I would have here 2 over the square root of h plus 4 minus f of a, that is 1. I would write here 1 over 1, then divided by h. Let's simplify the fractions in the numerator. I will start by multiplying 2 and 1 here. I would have here 2, copy the operation. And then next, multiply this 1 and square root of h plus 4. And that will be square root of h plus 4. Then divide it by the product of the denominators. And that will be square root of h plus 4. Then all over h. We have here division of fractions. To simplify this one, just place this denominator here to the denominator of the numerator. So its simplified form would be 2 minus square root of h plus 4 divided by h multiplied by square root of h plus 4. To further simplify this one so that we can solve for its limit, I would have to remove the radical in this numerator here and this h in the denominator. To do that, I would have to multiply both the numerator and denominator with the conjugate of the numerator, and that would be 2 plus square root of h plus 4 all over 2 plus square root of h plus 4. Let's simplify. Let's start with the numerator. In the numerator, I have here difference of squares. So its simplified form would be 2 times 2, that would be 4. Then the product of negative square root of h plus 4 and positive square root of h plus 4. So with that, the radical will be cancelled and I will have here negative h plus 4. Then just copy the product of the denominator. I would have here h times square root of h plus 4 multiplied by 2 plus square root of h plus 4. Next, I can simplify this 4 and 4 here since we have here a minus symbol. I will be left with negative h in the denominator. Again, just copy the denominator. So I'd have here h over square root of h plus 4, then multiplied by 2 plus square root of h plus 4. Next, I can cancel this h in the numerator and h in the denominator. And the simplified form of our function here would be negative 1 over square root of h plus 4 multiplied by 2 plus square root of h plus 4. Since it is already in its simplified form, I can now plug in the value of h here to solve for its limit. So I would have here negative 1 divided by 0 plus or 0 square root of 0 plus 4 multiplied by 2 plus square root of 0 plus 4. So its answer here would be negative 1 divided by square root of 4 is 2 multiplied by 2 plus 2. So the slope of the tangent line here would be negative 1 over 8. Now to solve for the equation of the tangent line, we can still use the point slope form. Y minus y sub 1 equals the slope of the tangent line multiplied by x minus x sub 1. Though not stated in the problem, x sub 1 is just the value of a, and that is equal to 4. And y sub 1 is our f of a, and that would be equal to 1. So plugging in the values, I would have here y minus 1 equals negative 1 over 8 multiplied by x minus 4. I can distribute negative 1 over 8 to the factor x minus 4. I would have here negative x over 8 plus negative 1 over 8 times negative 4, that would be 4 over 8 or positive 1 half. Copy y minus 1 on the left side. Then for my final answer, I'd want it to be in the slope-intercept form. I would have to transpose negative 1 to the right side. So I would have here y equals negative x over 8 plus 1 half, then plus 1, or simply the final answer is y equals negative x over 8 plus 3 halves.